Okay, so today's lesson is called Simplifying Algebraic Expressions. Okay, and what we're going to really see is in Math 7, I actually call this lesson what it is, and that is we're going to be combining like terms. Actually, in this class, though, we'll use, that's kind of what we're learning about, but then you're going to see a lot of problems mixed in that have distributive property, or where we need to use distributive property as well. So what we're doing is we're simplifying algebraic expressions using a lot of things, all right? But let's go ahead and talk about some of the words that you guys will need to understand to make have the lesson make sense, okay? So here we go. All right, it's very tiny, so you're going to need to listen carefully. It's just kind of what the font is. It went that small to get them all on this paper. So here we go. The very first word, guys, is something called a term. Everyone? Okay, so when it comes to math, here's what your book says a term is. It says it's a number, a variable, or a product or quotient of numbers and variables. Okay? So, a lot of these, the examples are going to help a little more than usual. So here we go. When it comes to terms, all right, I'll go ahead and rewrite this a little larger here. So a term could be a number. So for example, in your little box, go ahead and put 8. 8 would be considered a term. It could be a variable. So it could be something like x. That could be a term. Then it says it could be a product of a number and variable. So for example, we have something like negative 3y. That is actually a term. It can also be the quotient of a number and variable. So for example, we have something like the variable p divided by 2. Those are all considered terms. Okay? We'll add on to this here in a second. Here we go. Our next word is coefficient. Everyone? Coefficient. All right? A coefficient is the numerical part of a term that contains a variable. The numerical part of a term that contains a variable. So, in your little box, go ahead and write this down. 2v. The term 2v, 2 times v. The coefficient, underline the 2. The whole thing's not a coefficient, it's just the 2. That's called a coefficient. It's a number that's multiplied in front of the variable there. So another example would be something like negative 7c. Negative 7 is the coefficient. All right, our next vocab word or phrase is like terms. Everyone? Like terms. Okay, so we know what a term is, any of these, but what is a like term? Well, here's what the book says. These are expressions that contain the same variables to the same power. Expressions that contain the same variables to the same power. So, for example, m and 9m, those are like terms because they both have the same variable. And just where you know where it says to the same power, this right here is to the first power. Even though we don't put an exponent there, that's what that really is. Okay? Also, I want to make sure I point this out. 6 and 8. So, but Mr. Wilkins, those aren't variables. Yes, but they are numbers. And when numbers are by themselves with no variable, they are like terms to each other. Not to these, just to each other. Okay? Something like negative 2y and positive 7y. Those are like terms. They both have the variable y in them. However, in your little box there, put this. Here's another example that something that's not like terms. 4m and 7y. Those are not like terms. Or even something like 6x and 5. Those are not like terms. One is a number, one has a variable x. Up here, these are two different variables. All right, our next word is constant. Everyone? Constant. Okay, so those of you that love to read, good vocabulary, right? What does it mean for something to be constant? You could say to repeat. I don't know if that's the best definition, but that is something that does pop in my head too.
It's like
always. Or
to happen again.
To happen again. Okay, it's kind of like a smaller version of repeating. I would say always, or better yet, kind of saying the opposite is something that's constant doesn't change. Okay? Well, when it comes to math, what doesn't change? Well, I tell you what, that does. Today, problem number 1, maybe the m is equal to 5. Tomorrow, maybe problem number 6, the m is equal to -2. It just depends on the problem. Okay? However, there's something that doesn't change, and here it is. Your book says it's a term without a variable. A term without a variable. Here's what I'm going to tell you it is. A number. Ladies and gentlemen, in first grade, that number right there was represented by this many. Right? That number right there this year is this many. That number right there, when you are 80 years old, is going to be that many. Doesn't matter. It doesn't change. It's always that much. That's the value always. So that's why they call a 5 a constant. Something else that's a constant is even negative numbers, so integers, -9. That would be a constant. Okay. Now comes the next definition, and that is simplest form. Everyone?
Simplest form.
So here's what they say. You say, well, Mr. Woods, we already know what simplest form is. Well, maybe, maybe not. You know what simplest form is like if you're doing calculating fractions, right? You go, oh, simplest form, I need to reduce. Okay, you probably have seen simplest form a lot. But what about when we're talking about expressions? Well, here's what your book says. It says an algebraic expression in simplest form has, condition number 1, no like terms. We just talked about what like terms are, things with the same variables. And we talked about this earlier, no parentheses. If it has parentheses or it has like terms, then you know it's not in simplest form yet. All right? So, here we go. I'm going to go ahead and write these over here. Here's some examples. Well, here's one. 6x plus 5. 6x plus 5. No parentheses, no like terms. We have a 6x and a 5. However, let me show you better yet a couple of terms that are not in simplest form. 2y plus 5 plus 4y. Okay? Two like terms in there, that wouldn't be simplest form. You'd have to get rid of the like terms. And that's, of course, what we're doing today. Here's another one. 4 times 3n. Something that is like that. Now, we've talked about it, right? Distributive property, you've already learned. Distributive property we use, like we did in our POD, because it's not in simplest form, because you have those sets of parentheses there. We can simplify it even further. And that's why we do that. Well, today we're going to talk about the other half of this, meaning that there's no like terms. Okay, and then your book has this in there, simplifying the expression. Everyone?
Simplifying the expression.
To use distribution to combine like terms. To use distribution to combine like terms. All right? So that's something that might show up in your directions. It's a little less important, but still, if the directions say it, you'll need to know exactly what it's talking about. Okay? So, with that said, I am going to post a question up here. Here it is. Why do terms have to be like, meaning like terms, to add them? Now you might be saying, well, oh, they do have to be like terms to add them? Well, that's what we're going to talk about right now. Now let's talk about this just really quickly. In elementary school, back in 3rd or 4th grade, when you guys first learned about multiplication, 4 times 3, okay? What multiplication is, it's repeated addition. What this really is it's 4 of these added together. So that would be 3 plus 3 plus 3 plus 3. That's what multiplication is. Now, what about 4 times C? Well, here's what it is. It's 4 of these added together. C plus C plus C plus C. Same kind of thing. It's just a variable. Okay? So same idea. Now I'm going to take it a little further. What if we have 2m plus 3m? Well, let's expand it like this right here. 2m would be m plus n. 3m is m plus m plus n. I'll just bring this addition sign down. Now, let's simplify this. What is this, guys?
5m.
5m. Let's talk about this. What about 1y, or I'll just say y, plus 5y? Well, I'll bring this y down. It's just by itself. It's just one of them. 5y's, right, is y plus y plus y plus y plus y. Bring this addition sign down. This was a 1y, right? What is this? So let me ask you guys something. I want you, don't shout it out. I want you to take a look and try to come up with your own rule of how do you go from here straight to the answer instead of having to expand it out and do all that work. How would you go here and without expanding it out, go straight from here to here? And find a rule that would work both on both problems. Okay, now who thinks they may have the answer? All right.
You just add the numbers.
Which numbers?
In both of them, which the first one is 2 and 3, and the second one is 1 and 5.
Okay. Does anyone remember what those? Who can tell me what's that number called, Jaden? Ooh, that's pretty good. Using math terms, I like that in here. Good job. All right. And agree, disagree. What do you guys think? So here's the rule. When you are adding terms, first of all, they need to be like terms. And when they are, you add the coefficients to get your simplified term. 2m's plus 3 more m's equals 5m. 1y plus 5y's equals 6 total y's. All right? Nicely done. All right, I saw a lot of hands go up. It looked like a lot of you guys had a good idea. Okay? Now, what about this? Here we go. 2x plus 5y. Anybody? Ah. It's not 7xy? No. Think about it, right? There's 2 x's and there's 5 y's, but you can't do it because there's not 7 of anything. There's just 2 x's and 5 y's. This is simplified form. Okay? So why do terms have to be like to add them? This is the reason right there. Okay? It doesn't work otherwise. All right? So what we're going to do is we're going to use this skill All right, this idea to simplify a bunch of algebraic expressions today. All right, so let's go ahead then and grab your book, grab a piece of paper. There is none on that one. All right, thank you those of you that have eyes up here, ready to go. Okay, here we go. Let's take a look on page 301 and look at problem number 4. Problem number 4. Problem number 4 gives us 3a, sorry about that, 3a plus 5b plus 4 plus 6a. All right, here we go. Step 1 is what we're going to do is we're going to ID, I'll put our LT for like terms. We're going to identify our like terms. Okay, here's how I want you to do it on tonight's. Now, what I'm hoping is by the end of this chapter, we don't have to do this anymore, but I do want you guys to get used to this. I'm going to go ahead, I'm going to start with my first term. My first term is 3a. So I'm going to go ahead, I'm going to just use a box. If you want to use a triangle, a circle, whatever, if you want to highlight it with a highlighter, feel free. I don't care. Whatever, you be creative on that if you want. But here's what I am picky about. Whenever you do it, you need to also, whatever you do with the a term, I'm going to look here and do with any other a term. And here's another a term. It's a positive 6a. Now the other thing I'm picky about is putting a box around it. Include the sign to the left. That's extremely important, especially as these problems get harder. Okay? Now, I just ID'd one like term. Step 2 is I'm going to put repeat. Now, here's the issue. 5b is, I'm going to go ahead and I'll circle the b term plus positive 5b. I can circle all my other b terms, but there are none. It's by itself. It's a loner. Okay? Plus 4. That right there is a constant. It doesn't have a variable. So, I don't know. Maybe I'll put a triangle around it. Try to, of course, like I said, keep your sign inside. Okay? Step 3 is we're going to go ahead and combine. Combine means adding and subtracting. So here we go. I have my 3a plus 6a. What is it, everyone? 9a. Now I have my plus or my positive 5b. I'm going to go ahead and just bring that down because that doesn't have a like term. And I have plus 4. Okay, now what I just did is I just showed you how to combine like terms. The issue with that is that I was getting ahead of myself because problems 1 through 6 want you to identify the different parts of the expression. So my lesson is always read directions. All right. So, first of all, let's use this, even though those weren't the directions, that is part of our lesson today. All right? Any questions about the steps? Any questions about the steps? Okay? Now, if you take a look, let's take a look at those top directions, all right, for that section. And I'll show you what they expect out of that section besides, they don't want you to do this to that. all right, to that section. So take a look. Let's close read the directions. It says identify the terms, like terms, coefficients, and
Constants.
in each expression. So here we go. Let's take a look at problem number 2. Okay, we have 2x plus 3x plus 4 plus 4x. So, believe it or not, step 1 is exactly the same. I'll do this in blue, considering that it's very close to our last one. Okay, so I'm going to go ahead and ID our like terms. So 2x plus 3x and a plus 4x. I do have a constant there. I'm going to go ahead and circle it. Now, step 2. Go ahead and label all the different parts of this. So we have, it's asking for the terms, so I'm going to go ahead and write terms with a colon. Like terms, coefficients, and constants. Okay, so here's what we're going to do. Step 3 is we're going to just go ahead and label all these. So we have terms, right? We're going to go ahead, all 4 of these are terms. That's why we identified them to begin with. So we have 2x, comma, positive 3x, comma, positive 4x. Along with, of course, the 4. They're all terms. That's why we boxed and circled all the different terms. Now comes like terms. We are only labeling down the ones that are like. Well, we have a little code here, right? All of the boxes we can put down. So 2x, positive 3x, and positive 4x. Okay? Coefficients. By the way, guys, does 4 have a like term? No. If it had like a minus 6 over here, I would put like a slash and put 4 and a minus 6, or negative 6. Okay, make sure you put a slash, don't put a comma, because that's saying that they're like terms with the rest, and that wouldn't be accurate. Okay, coefficients are any number that's multiplied with a variable. So if we take a look here, these are our 4 variable terms. Coefficient is a 2, a 3, and a 4. Those are all of our coefficients. If this, for example, is a negative 4, you want to put negative 4 here because that's all part of the coefficient. But that's not the case here. Our constants are just our numbers, and in this case, it's just a 4. So it's just a way to test your vocabulary in that section. Okay, questions on that one? So number 4 is just like that. Yep. And then also what? Number 6 as well. Well, number 4 we already did, right? So no, we didn't. You would do number 4 like that, sorry. Yes. And then number 6. Okay. Now, what we're going to do is let's go ahead and take a look at 301, problem number 40. Problem number 40. It ends up going over to 302, right? So number 40 is 2/3 times the sum of 6a plus 3b minus 1/2 times the difference of a minus 2b. Okay, so let's go ahead and take a look. Step 1, do distributive property. So if we take a look, we have 2 sets of parentheses. Believe it or not, those are 2 parts where we're going to do distributive property. Only take one at a time. So take a look. I'm going to have my 2/3 and I'm going to multiply it with 6a and a positive 3b. So take a look. I am not doing multiplying with a negative 1/2. That is not in the parentheses. That's not part of distributive property. So 2/3 times 6a. You say, well, Mr. Wilkins, you can't do that. They're not like terms. That's what some people say. Don't say that, because we're not adding or subtracting these. We're multiplying. What this really is 2/3 times 6 times a. So all we have to do is multiply the 2/3 and the 6, because it's multiplication. So I can go over to this side. 2/3 times 6 over 1. Cross reduce. And we get 4 over 1, or 4a. Two-thirds times 3b. 2/3 times 3, or 3 over 1. Cross reduce is 2 over 1, or just a positive 2b. Now I'm going to do it for the second half. Here we go. Negative 1/2 a and negative 2b. So negative 1/2 a, I'm sorry, negative 1/2 times a is negative 1/2 a. Negative 1/2 times negative 2. If you don't already recognize that, here's what you're doing. And that, of course, becomes 2 over 2, which is a positive 1b, or net positive 1 times b. Now comes step 2, and that is I'm going to combine like terms. So notice what I'm going to do is just what we did up here. Box in my a term. I look over, box in this a term. Circle this b term. Circle that b term. 4 minus 1/2 is what, everyone? 3 1/2 a. Most of the time, I'm going to be okay with that for today. Most of the time you'll see it as an improper fraction. 2 plus 1 is positive 3b. So realistically, this would be 7/2 a plus 3b. All right.